Okay, so welcome back. So we've just talked about essentially what the search space is, what a search tree looks like, what we're storing in a search node, and now we're finally moving towards the actual algorithms we'll be interacting with, which is I think mostly the fun part here. We're getting rid of the bookkeeping and we're moving towards different types of search strategies. So first I'm just going to define what actually is a search strategy, and this is just this is the order in which we choose to expand nodes. So we've already seen, right, that in the search tree we have these we start at the root node and you're going to generate children, but which one of those you then expand, look at first to generate more children and to grow the tree, that choice there is what defines a search strategy. Okay, so we've just talked about the idea that a search strategy essentially just corresponds to the order in which we're going to explore the tree, right? So I've drawn up a situation here where the blue nodes are nodes we've already expanded. We've already explored them during search. Including this one down here, I'm just saying, hey, it happened to be a dead end, right? It generated no children. Some nodes, like this one, generated only one child, right? Now we're left with what would be our frontier, our open list. So these three yellow nodes here are on the frontier. They're still nodes we could choose. Which one of these is best? Do you know which one of these is going to go to the goal faster? We're going to need some form of strategy, some form of rule essentially, in order to try to choose this, okay? So there's many of these, right? So this video is just going to talk about some of the popular versions of that. I think these are very intuitive. You can come up with a lot of these on your own. And the list here is definitely not exhaustive in any way. I'm just going to list some of the common ones. So let's just look at the search tree, right? And then you can kind of come up with different rules. We don't know which one's going to perform better right now. So any kind of guess works. One of the ways, perhaps, is, hey, this one's the furthest down. Let's just try to keep going downwards fast, right? So we're just essentially doing like a deep dive down the tree. So we would call this one depth first. This is a very popular strategy, and we'll talk about what that looks like and how it interacts later in the next video. Similarly then, perhaps instead, why don't we try to go wide first? Radially outwards, horizontally, however you want to describe that. Essentially, we're progressing search at each level of the search tree. That strategy would be called breadth first. Okay, so these are two of the very, very common ones. This will be called DFS, this will be called BFS. These are things you've probably seen in your Introduction to Computer Science course. If you haven't, we'll talk about it in the next lecture, and I think they're quite fun, and you'll really start your journey into search. So these are the first fundamental ones you look at. But now, how about we consider cost again, right? In the initial problem we saw before, some of these edges might have different costs. So perhaps we want to explore the tree in terms of some smallest cost. So we're going to just call this best first, okay? So we have some form of judgment, whether it's cost or some other metric. We're deciding separately, hey, this one is the most promising right now. It has the smallest cost. This and this node have a cost of 3. This one's going to be higher. Okay. Also, I think what's inherent in all of this is there's this aspect of tie breaking, right? Sometimes nodes might look the same on the search tree, and that's its whole different world. It's usually pretty simple. Sometimes we just do random, and random works surprisingly well. But yeah, so just also note that the tie-breaking aspect of all of this does exist as well. But you know, when we're talking about the strategies itself, it's that global viewpoint of ranking the nodes, and then tie-breaking can kind of come in and play with it thereafter. But if two nodes are ranked the same because of their depth, it's depth first search. Finally, this one we're not really going to talk about in the subject too much, but there is actually a fun version of problems where instead of just searching downwards from the tree, so from the initial state or from the goal state, there's the idea that we could do bidirectional search from both directions at the same time, and you're trying to search for the location that they will cross, right? Two different versions of the paths link up, and we can find a solution that way. So it's a really, really interesting idea. This is what we call bi-directional search. So we're not going to talk about that too much in this class, but I just thought it'd be interesting to mention it. And there are some really fun algorithms in the literature that do this. Okay, so this is essentially some of the most popular search strategies. I just wanted to go over those in this video. And now we get to begin our deep dives into each of these strategies and to actually start to engage with the real algorithms and see how they behave, and then we can start to solve actual problems. So please join me there. See you soon.